Hey guys, this is Angles Day 1, and today we really covered the foundational elements that you are going to need to know for this unit. We went over a lot of terms and a few of our angles rules, and what I drill into 6th graders at the beginning of this unit is that it's not difficult. This unit is really fun. It's logical. We don't have any word problems. We get to do a lot of just kind of figuring out by searching for clues, the measures of angles. But if you don't memorize the rules up front, then the unit is really, really difficult. And so the things that we're going over today are review concepts from last year, but you really need to memorize them, okay? So take good notes, pause the video as you need to, and make sure you understand what I'm talking about. If there's anything that you need clarification on, as always, please make a time to come see me. Okay, up at the top of your notes, you have quadrilaterals. A quadrilateral is a figure with 4 sides. Quad, you'll fill that in on your notes, means 4, and lateral means sides. The interior angles of a quadrilateral add up to 360 degrees. Both of these things are, actually all 3 of these things, are really important to remember. Quad means 4, lateral means sides. The angles add up to 360. Now, by the way, there is a quiz on this lesson tomorrow. The quiz is easy, don't worry, but it's mostly over terms like what you see in front of you. So again, take good notes and study them. Okay, a parallelogram is a quadrilateral with 2 sets of parallel sides. The opposite sides of a parallelogram are of equal length. So what that means is this is an equal length to this. That's why I have these 2 matching marks right here. And this side is equal to that. That's why they have matching marks. And the opposite angles of a parallelogram are of equal sides. So what that means is that this angle is equal to this one, and A over here is equal to A over here. Okay, make sure you have those in your notes. Trapezoids. Trapezoids are 4-sided figures with 1 pair of parallel sides. So you've got this side right here is parallel to that side. Or it could be these 2 sides, but in this trapezoid, it's the top and bottom. A rhombus is a quadrilateral whose 4 sides all have the same length. The rhombus is often called a diamond. Okay, now let's just pause here for a minute. Remember back to a few slides ago? What do the interior angles of a quadrilateral add up to? You should be thinking in your mind, Mrs. Jurgens, they add up to 360. I haven't forgotten that yet. Okay, so all of the angles in a rhombus, a parallelogram, a quadrilateral, any kind of quadrilateral, all the angles are going to add up to 360. And I had a student point out today, Darren, if you're watching, this was an awesome thing to point out, that when you can prove that the angles add up to 360 because, for example, in a rhombus, oh, my pen's not going to work right now. In a rhombus, you can draw a line down the middle and you'll have 2 isosceles triangles, and since the angles in a triangle add up to 180, you can conclude that all of the angles in a quadrilateral add up to 360. Okay, an equilateral triangle is a triangle in which all 3 sides are equal. All 3 internal angles are also congruent. Congruent means same, you guys. Congruent to each other and are each 60 degrees. Okay, so since the angles of a triangle add up to 180. With an equilateral triangle, since all angles are the same, it is 180 divided by 3, which equals 60. So every angle has to equal 60. Isosceles triangles are triangles in which 2 sides are equal in length. The angles opposite the 2 equal sides are equal. Okay, what that means is that I have 2 equal sides. They're signified right here by those lines. The angles opposite the 2 equal sides are equal. So that would mean this angle right here, since that's opposite this one of the equal sides right here, is equal to this angle that is opposite this side. Okay, see how that works? So those are equal. Complementary angles. Complementary angles are a pair of angles that add up to 90 degrees. For example, in my picture here, I've got an angle of 30 degrees and an angle of 60 degrees, and they add up to 90. Supplementary angles are angles whose measures add up to 180 degrees. like my picture here. I've got an angle that is 40 degrees and an angle that is 140 degrees. All right, let's talk about properties. I want you to draw a little circle and a line next to 360 and 180. So a circle is 360 degrees, and that's important to remember because it's going to come into play in just a couple of minutes. And when we talk about angle properties, and a line is 180 degrees. So when you just have a straight line, you have 180 degrees around it. And then you already have this written on your notes here, but angles within a triangle all add up to 180 degrees. Hopefully you remember that from last year. And then angles within a quadrilateral all add up to 360 degrees. Okay, let's talk a little bit more about complementary angles. Two angles are called complementary angles if the sum of their degree measures equals 90 degrees. So right here I've got an angle of 58 degrees and an angle of 32 degrees. And if I add those together, oh, my pen, I don't know if it's going to, oh, it's going to let me write, good. 58 plus 32, I'm going to get 90. Oh, it just decided to quit on me. Okay, well, you get the idea. If we add those together, I'm going to get 90. One of the complementary angles is said to be the complement of the other. So 58 degrees is the complement of 32 degrees, and 32 degrees is the complement of 58 degrees. Okay, here's a little toyo, so go ahead and pause the video, and you're going to fill in the angle measurements of each of the question marks. So what I want you to do is subtract the angle that is known from 90, and whatever the difference is going to go in the question mark. All right, check your work. Hopefully you got 22 degrees up here, 37 degrees, 50 degrees, and 27 degrees. And that, again, is because, for example, over here, 90 minus 68 would be 22. All right, supplementary angles. Two angles are called supplementary angles if the sum of their degree measurements equals 180 degrees. One of the supplementary angles is said to be the supplement of the other. Right here we have a picture of a 139 degree angle and a 41 degree angle, and down here we spun that 139 degree angle and stuck it next to the 41 degree angle, and you can see that together they make a straight line. Okay, so go ahead and pause the video and try the toyo. This time you're finding the measures of the angles with the question marks, and you're going to subtract the known angle from 180 degrees. All right, go ahead and check your work. Make sure you did your subtraction correctly. And then let's move on. Okay, vertical angles. So your next page looks a little different than what's on the PowerPoint here, but that's okay. Vertical angles are the angles opposite each other when two lines cross. So that is going to go at the top of your notes. Vertical angles are angles opposite. The interesting thing is that vertical angles are equal. So when I have two lines crossed, like I have in my picture here, angle A is equal to angle B. So let's take a look at what's on your page. So what that means is when I'm looking at this question mark, for example, or angle Q right there, I look at the vertical angle across from it, which is 106 degrees, and I can conclude that this angle, is also 106 degrees. And because of the same property, this angle right here is 74 degrees. Go ahead, pause the video, and fill in the rest of the angles, please, on this page. Okay, go ahead and check your work. And then let's go ahead and move on. All right, I think you all know what right angles are, but just by way of reminder, right angles are angles that are 90 degrees. Right triangles are triangles with a 90 degree or right angle. So here we've got a right angle right here. We're very familiar with right angles, aren't we? All right, angles around a point. Angles around a point always add up to 360 degrees. Go ahead and fill that in on your notes. Okay, so let me explain this. When I've got a point, if we were to draw an imaginary circle around all these angles, we would know that there were 360 degrees in that circle, right? And if we were to divide up like this all the way around and just divide into 1 degree segments, we would come up with 360 of those. So just by visualizing that, it's easy to see why angles around a point equal 360. But that is one of the angle properties that you're going to want to remember. So let's stop and let's find the measure of angle A right here on your paper. And what I'm going to do is we're going to add up these angles. We have 124, 93, and 72. We're going to add those up and then we're going to subtract them from 360. All right, so I've added up 124, 93, and 72, and I got 289. And then I subtracted 289 from 360, and I got 71. So 71 degrees is the measure of angle A. Okay, go ahead and find the measures of the angles with the letters inside them on your paper. That's just a real quick toyo, so go ahead and pause the video and do that right now. All right, go ahead and check your work. Hopefully you got what I got. Okay, let's move on. So I'm going to kind of gloss over the triangle properties really because we're going to hit this a little bit harder tomorrow. So I'm going to go through these really quickly, and I don't have any toyos, but that's okay because we're going to do this again tomorrow. So the sum of the measures of the three angles of a triangle is 180 degrees. Go ahead and fill that in your notes. And I've already mentioned that, and I know that you know this from last year, but by way of reminder, an equilateral triangle is a triangle in which all three sides are equal. I mentioned that earlier in the video. All of the angles are also equal to each other, and they are each 60 degrees. And again, with the isosceles triangle, triangles in which two sides are equal in length and the angles opposite the two sides are equal. Okay, so that was just kind of a repeat of what we learned earlier. So now we're going to kind of talk about alternate angles. We're going to talk about alternate exterior angles and alternate interior angles. And tomorrow you're going to get a little card with angle rules on it that you need to remember, but it's a helpful little tool for you to study from. And the rule that we use with alternate exterior and interior angles is called the Z rule. So let me just explain what these are. For any pair of parallel lines that are both intersected by a third line, such as line 3, down here, angle A and D are called alternate exterior angles. So let's just look at what I mean here. I've got two parallel lines, right here and right here. They're intersected by a third line. The angles that are out here, A and D, are called alternate exterior angles. They have the same degree measurement. B and C are also alternate exterior angles. So B and C are also equal to each other. That's why they have two lines signifying that they're equal. And then A and D are equal to each other. The reason I call this the Z rule is because you can draw a line starting at the top, down the intersecting line, and over the bottom to just see where the angles are that are equal. Up here, the angle C borders the top of the Z, and angle B borders the bottom of the Z, so those are equal. And the points of the Z are pointing to angles D and A, so you can tell that those are equal. Also, just visually, when you look at these two parallel lines with the line intersecting, and in case you can't remember the Z rule, you can look at this and you know, okay, I know that there are some sets of angles around there that are going to be equal. I just need to remember which ones they are. Visually, you can see that C and B are equal to each other if you know that there's a rule behind it. All right, alternate interior angles are similar. So with alternate interior angles, now we're looking at the angles on the inside of the Z. Okay, so we've got angle C is equal to angle B right here. They've each got two lines. And angle D is equal to angle A. Okay, so with C and B, the Z is surrounding them, I guess. And angles A and D are flank the diagonal of the Z. This is also because of the Z rule. All right, so I've reached my time limit for today. So go ahead and give that alternate angles worksheet a try on the next page of your notes, but this is where we stopped for today for day 1. So if you've gotten this far, you're all caught up.